Walk into any Indian market at the height of summer, and you will be hit by an invisible wall. It is the heavy, sweet, unmistakably tropical scent of ripe Alfonso mangoes stacked in the heat. Before you even make a conscious decision to buy one, your body is already reacting. Your mouth waters. A deep, instinctual craving takes over. That scent bypasses your brain's logical, cognitive filters. It injects a chemical signal directly into your limbic system, the brain's primitive survival center. This intense psychological response stems from an ancient biological strategy. The fruit uses these specific chemicals to signal a high-energy food source, triggering a reaction before the conscious mind intervenes. In the wild, a fleshy fruit has one specific biological job: to convince a mobile animal to swallow its seed whole and drop it in a new location. But the mango presents a glaring anatomical paradox. Beneath that sweet flesh is the gutly, a massive, recalcitrant seed wrapped in a thick, woody, fibrous shell. This diagram compares the diameter of a mango stone to the narrow throats of humans and modern primates. It is physically impossible for us to swallow and pass this intact without choking. No modern animal in the mango's native habitat can fulfill this fruit's primary biological objective. The mango's chemical trap evolved for a creature that no longer exists. The mango originated in the dense, highly competitive jungles of the Indian subcontinent during the Pleistocene epoch, over 2.5 million years ago. To survive here, the plant adopted a strategy known as the megafaunal dispersal syndrome. It produced heavy fruits to attract prehistoric mammals weighing over 1,000 kilograms. The fruit releases a complex cocktail of volatile organic compounds, or VOCs, like terpenes and esters, to signal those giants from a distance. This specific formulation cuts through the dense, competing odors of a thick jungle canopy. This scent functions as a specialized high-energy homing beacon designed for the giants of the Pleistocene. Those targets included massive, extinct herbivores like giant ground sloths and elephant-like gomphithers. The symbiotic exchange was simple. The giant consumes the fruit whole, digests the soft flesh, and deposits the intact seed miles away in a pile of nutrient-rich fertilizer. But the sudden extinction of the Pleistocene megafauna created an ecological crisis. The mango was left as an evolutionary orphan, burdened with an unmovable seed. The mango should have gone extinct alongside the giants. Instead, its chemical signature was so compelling that it attracted a new transport species, Homo sapiens. Driven by the fruit's aroma, early humans in the Indian subcontinent began domesticating the wild mango over 4,000 years ago. The Mauryan Emperor Ashoka issued edicts ordering the planting of mango groves along major trade routes to provide shade and sustenance for travelers. Later empires continued this obsession. The Mughal Emperor Akbar cultivated an orchard of 100,000 mango trees in Bihar. The teardrop shape of the unripe mango, or kairi, transcended agriculture. It became woven into the region's art, textiles, and cultural identity. By elevating the fruit to a symbol of royalty and embedding it in infrastructure, humans became a far more effective seed disperser than any extinct giant could have been. Over the centuries, human selection leveraged the mango's original survival chemistry, cultivating nearly 1,000 distinct commercial varieties across India. This branching tree illustrates that genetic explosion. We selected for specific traits, from the saffron-tinted Alfonso to the floral notes of Bombay green and fiberless hybrids like Malika. The fleshy, sweet mangoes we eat today represent the extreme results of human intervention layered over an ancient biological trap. The mango survived global extinction by being so chemically irresistible that humanity ultimately conquered the world on its behalf.